All right, let's go ahead and get started. The lights are pretty low. I feel like I should light some candles and maybe put on some Kenny G or something. But instead, we'll talk about PDF.js. We'll save that for another talk. So just a little about me. I'm a software engineer at Mozilla. I work in the labs group, and I'm currently the technical lead of the PDF.js project. So in this talk, I just kind of want to go over the creation and evolution of PDF.js. And some of the issues we ran into along the way, creating this thing that would usually be a native application with we created only purely HTML5. So yeah, let's get started. So first, to give you a little bit of background, I wanted to go over the PDF format just a little bit, just to give you a little more context of what we're dealing with and what we need to do to actually render a PDF. So if we go back to 1991. That was when Camelot was first introduced, and Camelot became PDF in 1993. So it was a format that was based loosely on PostScript. So if anyone's familiar with PostScript, it will look similar when I show you some examples here. I still yet to meet anyone who actually writes PostScript, so if you do, there we go, got one. All right. So the format itself started out as a pretty clean, elegant format. It's a simple structure of different data types that you'd see in most programming languages, actually, like booleans, strings, kind of a dictionary object, and things like that. They're also broken into this kind of tree layout, which is also similar to a lot of things you'd see in programming. Unfortunately, like many things over the years, it developed some additional add-ons that kind of, when you see a PDF, you kind of expect just to be kind of a document or something like that. But it got a whole bunch of fancy new features that I'm a little skeptical about what they really added to the format itself. So some of those things that were, unexpected, I didn't know about any of these actually until I started working on the PDF.js project. So PDF within it has a 3D modeling format that is totally different. You can do 3D models in PDF. There's video and audio, which I can kind of see that, but if you're thinking about just printing, that doesn't make any sense. There's attachments. So this was a common way viruses were distributed, actually. You could embed attachments within a PDF. It would get around the virus scanner. And there's actually Flash within PDF, so you can embed Flash. And JavaScript, too. There's full JavaScript engines in Acrobat, and we'll have one in PDF.js, too. So we jump ahead to 2008. PDF itself became an ISO standard. So this is something a lot of people don't know, that it actually is a standard now, and it's fully open. The standard itself is something like 750 pages. So it's a really big spec, but it's actually really a spec of specs. The spec itself, I think, links to over 40 different other specs for file formats that are within PDF. So you really, it's quite a document. So yeah, next, let's just go into like what's inside a PDF. Again, just to give you more context of what we're dealing with and how we render a PDF. So all PDFs are basically in this layout. So at the top there, you've got the header, which you could consider that like the doc type in HTML. It just tells you, it's a PDF and what version the PDF was created for. Next, you've got the body, which is where all the content basically is. Everything is an object in a PDF. So you've got all these objects. You can see up top there it says 20 obj, which stands for object, and the 20 is the identifier for the object. And there will be a whole bunch of those in the body. Next, you've got the xref table or cross-reference table. This gives you the location of every object within the body. So if you've ever been viewing a PDF and you're like, why is it taking so long to show this? It's downloading the entire thing. It's because it's waiting to get that table so it can look where objects are in the file. This is changed with later versions of the spec. There's actually a way to embed this throughout the file, which makes it better for viewing on the web where you're downloading kind of in order there. There's also the trailer. That just points you at important objects. So this one points you at the root, which is the root of the tree. That's where all the pages live, and it's the root of this object tree. And I'll show you a little bit more on that now. Oops, clicked off. So this is just a little demo, well, a little thing I whipped up with PDF.js. This is actually loading a PDF document that I have locally here. Yeah, it's a little hard to see here, but so here you can see this is kind of a tree structure. Here I open the info. That will just tell you, basic information about what created the PDF and things like that. The root here is actually, like I talked about before, the root where it's got all the pages. The pages are in a tree-like structure with, kids. You can descend down into this and see if we can get to an actual page here. So yeah, I'm just descending down. You can go into the kids. I finally got down to the first page here. You can see, it's got just lots of keys and values and things like that. And I think the content streams, this is actually what's in a PDF page itself. There's a whole bunch of content you can browse through that. And like I said, I should mention down below is the link to actually, if you are bored and you want to look what's in a PDF, you can browse and open one up and go through this tree and look at all the structure and whatnot. So just to go a little more into what's in that page object itself, this is what is in a page stream. So again, we've got on line 1 there's the 5.0 object. And that's just telling us that this is the start of the 5 object or the 5.0 object. We then have the 2 less than signs. That's telling us it's a dictionary. So the next line is it has length 44, which is the key and the value. Whenever you do a slash, that's a name data type in PDF. Then you've got the 2 greater signs. That's closing the dictionary. Then we have the stream keyword, which that's opening the stream. And now we actually are getting into what are the drawing operations happening in this PDF. So you've got BT there, which stands for begin text. It's just telling the reader or the viewer that we're starting a text segment. The next one is 7050 TD. One thing to note here is the operands come before the operator in PostScript. So that's 7050 TD is saying move text to the 7050 location on the page. The next line, the /F112TF, that's setting the font to a font named F1, and the size is 12. And then the following line, 9, is actually where we're going to write hello world. And to make strings in PDF, you use parentheses, and it says hello world there, and TJ stands for show text, basically. Then we have end text, and then we're closing all the subsequent things we opened up down below. So there's end stream and end object. So just to see this a little more, we actually, in PDF.js, we have debugging tools. So you can watch the PDF render as it's going. So here I've loaded the PDF and I set a breakpoint on the first drawing operation. So I can just kind of step through those. And you can see the PDF is drawn, it's actually done word by word. And I think this PDF, the letters are actually kerned individually as well. But you can, just step through, and I can actually jump ahead, and then it'll draw the whole PDF there. So going back, we can go back to our kind of timeline, and we'll continue along here. And while we're continuing from 2008, you may have seen one of these come up on your screen on your computer, and maybe another one, or there were a few more during that time, and maybe one more. Hey, we made it to 2011. So in 2011, Firefox 4 launched. During that time, Andreas Dahl and Chris Jones were traveling a lot for some of the kind of launch events for Firefox 4. They were having a lot of time, or killing a lot of time in airports, so they were brainstorming on a project to create, and they came up with PDF.js. They wanted to make an application that really used all the new cool features in HTML5. So a question we get a lot of times is why would we create this PDF viewer in HTML5? It seems a little bit crazy to do something like that. The first one was security. So if you look at the release notes for Acrobat, you'll see a lot of security vulnerabilities getting fixed with each release. There are other viewers out there that are a little more secure. So Chrome has a sandbox PDF viewer, but the unfortunate thing is it's a proprietary binary blob, and sandboxes aren't perfect, as was seen in the latest they can be broken out of. It's harder, but yeah, they can be broken out of. So in HTML5, we have a whole bunch of APIs that are already exposed, well-tested, and pretty secure. And overall, we're exposing less code when we use PDF.js, which less code and less native exploits. The next thing is user experience. So previously, when I opened up a PDF on my computer, it was often kind of a pain point for me. It would switch contexts. It would, the keyboard shortcuts wouldn't work. It would open up in a new window or something like that. So we wanted to make PDF just kind of a streamlined format for the browser. The next one was performance. Some people think this is kind of a joke, making a JavaScript viewer that's performance. But if you think about what's really in a PDF, it's a lot of text, images, and vector graphics, which what does a browser do a lot of? Text, images, and vector graphics. So that's already all loaded by the browser. Everything's ready to go. We also have new JS engines, which are really, really fast. And we also have a GPU-accelerated canvas. So a lot of the drawing operations we do are actually accelerated by the graphics card. Another thing we wanted to do by building PDF.js is really push the limits of HTML5. So Mozilla's been pushing that the web is the platform and you can build anything on it. And what better way to prove this than build like a pretty complicated application that would previously only be a native application with HTML5. This way we could find performance bottlenecks and help out future developers. So now, let's jump into actually PDF.js. First, let's just walk through a little demo of PDF.js, though. So the nice thing about this is, since it's HTML5, this got messed up from reveal.js. So since it's HTML5, I can just embed it in my presentation here. And this is the viewer that's actually built into Firefox. And as you can see here, it scrolls nice and smoothly. It keeps up with my scrolling. It's got a lot of the standard things that a PDF viewer has, thumbnails. You can actually select text and all those things. So it's come a long ways, and it works quite well. You can zoom pretty quickly and just everything you want from a PDF viewer. And all the shortcuts and everything we try to map to browser shortcuts so they stay the same, like find is the same and all those things. And it just opens in a tab, it doesn't open in a new window or anything. So next, we'll dive into PDF.js. So how do we do, how are we rendering this PDF? So the very first thing we have to do, of course, is grab the data. This was really easy with XHR2 or AJAX. It now has a way of, you specify you want an array buffer from the XHR2, so we actually get a typed array basically back for the PDF, so we don't have to deal with a giant string, which can be slower. Once we have the bytes, we do the parsing and extracting. So this part's really relatively easy. We're just building a simple parser. It gets a lot more complicated by what's in the PDF. So PDF, the streams themselves, and the previous example I showed you was just plain text. But the majority of the time, those are actually decompressed with like Flate or PNG predictors or LZW. So we actually have libraries in PDF.js to do that decompression. It's further complicated. There can be encrypted as well, like with RC4 or AES. And those, again, are all written in JS and work pretty well. And yeah, this is, like I said, relatively straightforward until you get into bad PDFs, and there are a lot of bad PDFs out there. They don't follow the specification. So we really have to, a lot of our code is going back to handle these strange cases and see some very weird stuff in PDFs. So yeah, now that we have the bytes parsed. We start drawing on Canvas, and just curious among you, how many of you used Canvas before? So this will all look really familiar. So a lot of the commands in PDF, like we were looking at in that page stream earlier, map really well to Canvas. And you could argue that Canvas was kind of based on a PDF drawing model. So you've got, this first one here, we've got 2, 3. Again, operands are first, and that maps to context move to. Then this next one, we've got 4, 5, 10, 10 RE. That's building a rectangle, and again, it maps to Canvas really well, just creating a rectangle. And there are a lot of other commands for Canvas that map really well. Unfortunately, not all the commands mapped well, so we actually worked on trying to get these in the spec. So some examples here, dash lines. You could do it in JavaScript if you really wanted to. It would be really complicated and slow though. So that's been added to the spec. I believe Firefox and Chrome now support that. The even odd fill rule just describes how paths are filled. That's now in Canvas or in Firefox and Chrome as well. And extended blend modes. So previously Canvas only had porter-def compositing, which are basic compositing modes like source over, destination over, and whatnot. Whereas PDF supported different kind of blend modes where you could do like multiply or darken or lighten, a lot of stuff you'd see in like Photoshop or something like that. So that's added to the spec. And actually someone from Adobe implemented that in Firefox and Chrome, which is pretty cool since we're kind of collaborating on that. Another one is masks. Masks are a simple way of specifying like alpha transparency within a PDF. That's still under development, but hopefully we'll have that soon. So no, there's not just there's just not drawing shapes and everything. There are lots of images in a PDF. And unfortunately, PDF supports a ton of image formats, and the browser does not support every single one that PDF supports. So we ran into some issues early on with this. We were thinking about adding these image formats to the browser, but a lot of them were image formats we think that really, didn't belong in the browser, that already were replaced by better things. So luckily, I get to work with Yuri Delendik, who is a crazy JavaScript hacker, and he's created a number of libraries for working with image decoding. So down below you can see some of the libraries created. And you may be wondering about JPEG.js, because the browser supports JPEGs. But in PDF, there are CMYK color space JPEGs, which we cannot decode with the browser. So we decode those in JavaScript, then convert them to RGB, and then pass them to the canvas. And there's also JPEG 2000, which is JPX, and JPEG2. All libraries he wrote from scratch by looking at the spec. He's a pretty brilliant guy. But so besides images, there's also fonts. Again, PDF supports a ton of different fonts. The browser does not support all these fonts. So just to kind of give an overview of this, first you may be thinking, well, that's a beautiful flowchart, and yeah, I made that. And you may be thinking I should become a designer, but I think I'll stick to programming. So up there at the top, we've got the fonts that are in a PDF. So there's TrueType, kind of an open type thing that's in PDF, and Type 1 PostScript. And there's also Type 3. Type 3 is kind of the strangest of them all. Type 3 is actually the PDF drawing commands. So each little character that you draw in a font is actually like a mini PDF. So we actually use PDF.js to render those fonts, which is kind of crazy. But those actually are the simpler ones. So all these fonts we pass to the PDF.js font parser, which then creates kind of an object representation of them, and then we compile all these fonts and we sanitize them. And for Type 1, the PostScript, we actually have to convert the drawing operations within each character or glyph to a compatible one. And the reason we have to do this compiling and sanitizing and not just loading it into the browser is a couple of reasons. So one, Firefox and Chrome both use the OpenType sanitizer. They look at the font and they try and validate it and make sure it's not doing something malicious. Fonts are actually a common way of distributing viruses for a while, and the platforms aren't very secure about executing fonts. And also, all these fonts, they have to run on different platforms. And on every platform, you have a different font engine. And so if you create a font, it may not work on one platform. So we have to create a font that will work on Windows, OS X, and Linux. And if that wasn't hard enough yet, we then have to, there's also hardware acceleration, which turns on a different font engine on all those platforms as well. So the font code is actually probably the biggest piece of PDF.js. And it's all mainly parsing and sanitizing and recompiling these fonts into something the browser will like, or the platform will like. So then there's not just fonts and images. There's some other things within PDF. There's patterns, tiling, and gradient. Canvas supports some of these kind of patterns and gradients. Not all of the ones that PDF supports. I don't think we'll ever add support for some of the ones PDF supports because they're really kind of bizarre functions that I don't think they're really needed in Canvas. There's also color spaces. So in Canvas world, we all live in RGB, which is nice and happy. But in PDF, there's, I think, 7 or 8 different types of color spaces. So you've got one like CMYK. You've got full-blown ICC color profiles. And all of these we have to convert to RGB. And the last thing there is functions. The functions are used in a variety of ways. One of them is for mapping some of these color spaces. But like all functions, it's mapping input to output. And there are different types of them. Some of them are really simple, like linear interpolation or something like that. One's actually a subset of PostScript, though. So we have a PostScript parser and evaluator in PDF.js to handle these functions. So just another crazy thing that's built into PDF.js. Yeah, so just to give you kind of an overview of what I was talking about, we start with the binary format. Again, we decompress, decrypt, we parse, we create this kind of object tree and whatnot. And then we pipe it all into Canvas and render it. All right, so to get back to kind of the timeline, in August 2011, we had a PDF viewer. It worked pretty well, but there was still a lot we had to do. So we could draw to Canvas, and we could see everything. There are some other things you don't think about immediately when you think about a PDF viewer. There's text selection, which has actually been a lot harder than we thought. So PDF, like as you saw when the page was drawing, it's doing kind of line by line or character by character. So you don't have this idea of these nice divs or something like HTML. So we actually have to have an algorithm that looks at this and tries to group text. Else we'd be creating a div per character. And oh yeah, I kind of glossed over a point here. So for text selection, we're using a DOM overlay on the canvas, and it's actually transparent. And then, but it still shows, you can highlight it and whatnot. And one nice thing about this approach, though, is we do get accessibility for free. So screen readers can pick up this text layer and they see it, and it just kind of works well. So one thing I've learned with PDFs is text is really hard. It's a lot more complicated than I ever really thought about before. So one thing you kind of have to get away from is thinking of just a letter is a letter, like A is A, B is B. So here on this example, I've got a font on the left that would drawn in a PDF would just be squares and triangles, but when you copy and paste that, that's actually A, B, A, B, A, B. So just to further illustrate this, say you have a char code, which would be like what you would be passing to show text or draw text or something. And in ASCII, 66 is just F. You would think, oh, okay, that's easy. We just draw the letter F. But in the font, that may actually be mapped to a glyph that is the ligature FI, so which is 2 characters. And then, so we want to draw 1 character, or the 1 ligature FI. But then in the text layer, we want to break that apart into F and I. So then we have to be looking for that and figure that out. And another problem is not all fonts actually have proper Unicode values, so we have to have some heuristics to guess the Unicode values so text selection works. And there are tons of different ways to encode fonts within a PDF, and it's kind of a nightmare to deal with, actually. But so another thing, left to right and right to left. PDF was kind of mainly designed for left to right. You can really draw in any order, but left to right is more what it was made for. For right to left, when we have the text layer, we actually have to be looking at the Unicode ranges of the text, and if we see if it's like Arabic or something like that, we then have to run a BIDE algorithm on it to then start flipping the characters as we're putting them in the text layer, so when you copy and paste it, it's in the right order. And this is all really confusing. Luckily, we had an amazing contributor who spoke Arabic and wrote all of this code, so it works pretty well. So one of the, kind of going into some of the issues we had with PDF.js at this point, we had, I say, janky scrolling, or just like stuttering when you're scrolling. So it wasn't smooth. So to remedy this, we started using workers. And this is kind of one thing I recommend, is do as much as possible in workers if you're creating a viewer like this. So now pretty much we get all the data, we pipe it to a worker, we do all the parsing, and pretty much everything we can on the worker. But how many of you have used workers? So you probably know it's a little painful to use workers because you don't have the DOM or anything like that. So we actually have to still pass everything back to the main thread to execute on the canvas, or draw on the canvas, or create the text layer like that. And you're just dealing with message passing, which can get complicated. So even with that, we were still getting kind of janky scrolling when we were sending all these drawing operations back to the main thread. So what we did is we actually monitor while we're running these drawing operations how long we're taking. And we do it now in, I think, 15 millisecond bursts, which is, I think, 60 frames per second is the idea there. So then if we see we take too long, we set a timeout, so then the browser can do its reflows, repaints, and everything updates, and we don't hang the main thread. A third thing we do is we started to prioritize as much as possible what we were doing at the time. So right now we try and draw the page that is, obviously most visible. We also have, the pages can be paused. So if you're scrolling really quickly and the page goes out of view, we can pause that page while it's rendering, so it will stop rendering and not, it will switch to a new page and start rendering that one. And we also try and pre-render pages up or down based on where you've been scrolling. Just more little tricks to help with the scrolling issues. So we go back to the timeline. We're at April 2012, and PDF.js landed in Firefox nightly, and this was a pretty big day for us since we're pretty excited about it. We'd made it, we thought, but of course we weren't done yet. We had a lot of other issues that we had to come up with fixes for. So printing wasn't great, and we didn't have integrated find within Firefox, and then there were just a ton of bug fixes we needed to do. So all of those ended up getting fixed eventually. It took some time, and I won't go into the printing too much, but there is a new Mozprint callback API that we've added, but I don't know if it'll ever be standardized, unfortunately. We would be interested in it. We'll see, though. So continuing on, in January 2013, IonMonkey landed, which was Firefox's new just-in-time compiler, and it gave us quite a nice performance boost across the board because we were using typed arrays so much, and it could infer when it could just use the typed array data and whatnot. So yeah, that was a good performance boost, and I think that was Firefox 18 that landed. And then next, Firefox 19, it came out in February 2013, and we finally were able, we got to land in stable and stay on by default. Before that, we had stayed in the beta version of Firefox for a while just to get more feedback and try and fix more issues. But yeah, in February 2013, we finally made it into the stable version. And it's still the stable version, luckily. So again, we're still not done yet. I don't think we'll ever be done with the PDF spec itself. Just there's so much to implement, and not everything's actually used. So we can kind of jump ahead to the present and what's happened since February of 2013, like 10 months ago. So there's been tons of bug fixes. I think we've closed over 3,000 issues on GitHub during that time, so lots of bug fixes. We added range request loading, so we can now load a PDF without loading the entire file. So we had a great intern last winter who actually implemented this. So it uses XHR range requests to get chunks of the PDF, and then so we only load what we need for that page. This added a lot of complexities to PDF.js because previously we'd assumed everything was synchronous. So whenever you would get data from somewhere, we thought it would be available. And so we had all this code written for synchronous, and we had to switch it to async. So this is one of my kind of things to avoid if you're building a viewer is plan for asynchronous operations, because it's a pain, a big pain to rewrite once you have to add async into it. And we do use a lot of promises now, which I recommend those too. It helps with a lot of the callback hell stuff. So just to give you a little example of kind of the range request loading here, I've got PDF.js here. Let me refresh this. So this is a slightly modified version of PDF.js. Usually PDF.js will keep downloading the file while it's idle, but I've turned that feature off. So you can see up there the progress bar is only about a quarter of the way or a third of the way. So as I start scrolling, you can see the progress bar will go down, which it's loading more parts of the PDF, just what it needs as it goes. So we've thought about adding or using this for like mobile viewers and whatnot, where you don't want to be fetching tons of data and whatnot. So yeah, just going back. So another thing we added was incremental rendering. Before we'd parse the entire page and send over all the drawing operations, which turned out to be pretty slow. And then, we weren't using both threads, so it could also slow it down that way. So just to, you can kind of see this in action here. I have this bike map, which is a super detailed PDF actually. It's still a little bit slow, but I'll refresh it here. You can see it starts drawing like nearly right away. It's rendering as we go here. So it's sending, I think, chunks of 100 drawing operations at a time. So this PDF now I think takes about 6 seconds. Before the incremental rendering, it was taking 30 seconds to render. So it helped a lot with performance. So going beyond that, the current status of PDF.js. It supports the majority of common PDF features. We're still missing features I've talked about. It renders most PDFs quickly. We still have some problems with certain image types. And then some PDF creators, when they embed an image, they'll embed an image that's like 40 megabytes or something like that. And it's not slow on it's not fast on any browser or any PDF viewer. So we also have, we work in Firefox, Chrome, IE9, Opera, and Safari. So this is another thing. We tried to stay with the standards and we work across browsers so other people can use our library and then hopefully contribute back, and then we get a better PDF viewer and they get a PDF viewer for free too. We also have a Chrome extension, which actually has 290,000 users. I believe it's mostly Chromium users since they don't have the PDF viewer that Chrome has, but I'm not really sure about that, but it's still kind of cool anyways. And we're still, the default viewer in PDF, or in Firefox. So more on the kind of the timeline, jumping into the future, things we want to do. So we still don't support forms and JavaScript, which is, I think, kind of funny that PDF.js doesn't support JavaScript, but it's a lot more complicated because we have to support a lot of the APIs that Acrobat has for JavaScript. And then we also have to add, as a way to safely execute this, which is going to be complicated as well. So forms in JavaScript, that's one of the big missing pieces still. Soft mask, I think I talked about that before, but it's like alpha transparency for Canvas. Better text extraction. We have a new kind of foundation for this. We just need to kind of start using it. We want to make a text layer that lines up better with the actual content below. Right now, sometimes you'll see the letters don't quite align on the text layer. So we want to improve that. And we're always looking to improve performance as well. So I'm actually pretty excited about if anyone went to the Parallel.js talk, some of the stuff in there would really help us for image decoding and converting image color spaces. So again, just to kind of reiterate of some of the lessons I learned or some of the things I touched on. Plan for asynchronous operations if you're writing a really big JavaScript project. Like I said, it's painful to create or add it if you've written for synchronous beforehand. Do as much as possible in workers. Again, you need to kind of plan for asynchronous operations if you're doing this, since the workers are kind of async. And then unit tests. I didn't really touch on this before, but I think PDF.js could have been helped a lot by adding unit testing early on. It started out as like a really rapid prototype, but it's still, we've had some like kind of stupid little bugs that could have, I think, been caught by more unit testing early on. Be defensive. This is more advice if you're creating like a viewer for another file format or something like that. Within PDF files, we've seen just about everything possible. So you really have to handle all the weird, strange error cases when you're parsing the PDF, and you'll see everything. Because it's actually pretty hard to write a PDF, so you'll see lots of errors in them, and so be defensive. Like always, we're an open source project. We're on GitHub, and we have open project meetings. So once a week we have an engineering meeting. Anyone in the world can call in if they want to. We also have a triage meeting on Monday, so if you're really bored, you could call into that. We have mentored bugs too, so if you're interested in working on something, stop by GitHub or on IRC Mozilla, and we'll help you get started on a bug. And yeah, and we're at PDF.js on Twitter too. So yes, yeah, thanks for listening to my talk on PDFs, and that's all I've got for now. And I've got questions too. But.